Hi, I'm Margaret, and I'll be presenting switching between standard pointing methods with current and emerging computer form factors. Modern tablets and laptops support many different input methods. Some are absolute direct pointing methods like touch and pen, and some are indirect relative methods like trackpad and mouse. In the past, there have been works that examine the performance of pointing methods, like Cockburn et al., who examined the performance of pen, mouse, and touch, and Cassidy et al., who compared pen and touch. However, the sole work we were able to find that directly examines the time taken to switch between pointing methods was published 40 years ago. While evaluating text selection performance, Card et al. Found that it took an average of 0.4 seconds to move between keyboard and mouse. This indicates that there is a clear gap in literature for examining switching between input methods on modern devices. Our first study examined switching between pointing devices on a touchscreen tablet, specifically touch, pen, trackpad, and mouse. Our task was a modification of a 2D fits task, where tokens were arranged in a circle. Participants dragged a colored token to a target, indicated with dashed lines, then tapped the center target. Then they performed the docking task with the other pointing method used in that block. First, we hypothesized that the time to switch between pointing methods is asymmetric. This makes sense, as when you use touch, you simply have to move your finger to the target, while when using the mouse, you need to grasp the device, locate the cursor, then move the cursor to the target. This leads into our second hypothesis, that switching to an absolute method, like touch, is faster and less error-prone than switching to a relative method, like mouse. Next, we hypothesized that switching between methods with the same input mapping will be faster and less error-prone than switching between methods with different input mappings. The thinking is that the user can continue using similar motor movements for both pointing methods, without having to plan the switch and subsequent pointing action. Finally, we hypothesized that a switch involving the pen will be slower and more error-prone compared to the equivalent switch with touch, as switches with the pen require the pen grip to be adjusted or the pen to be tucked while using the other pointing method. Now, how do we measure the time taken to switch between pointing methods? We adapt the subtraction method from previous mode switching works. By flattening our task into a 1D representation, we can see there is a clear interval after tapping the center target with the red method and selecting the next docking token with the blue method, where the participant has to switch between pointing methods. Now, if we could subtract the time to use the red method on its own from this interval, we could get the raw method switching time for a trial. So how do we get these times? Again, we borrow from mode switching works. We bracket switching blocks with baseline blocks for each method used in the switching blocks. In these baseline blocks, the participants only use a single method, with no switching. By having baselines before and after the switching blocks, we compensate for learning effects. We used a within-subjects design with 6 switch conditions, so 1 condition for each pair of the 4 devices. There were 14 switch trials per block, or 2 turns around a circle, and 7 baseline trials per block, or a single turn around the circle. We recruited 12 participants, all of which were right-handed. Now here are our results for switch time. We found that switching between pen and touch was fastest, while switching to trackpad or mouse was slower. Next, we examined switching on a tablet-sized foldable device, pictured here. Again, we recruited 12 right-handed participants. We added a new hypothesis as well, that switching on the foldable device would be slower and more error-prone than on the tablet. We also slightly altered the task. Instead of using 7 docking tokens arranged in a circle, we used 8, with tokens placed symmetrically on and around the fold of the device, like so, where the blue line represents the fold of the device. Now for the results of our second experiment. We found that switch times were higher overall on the foldable device, and switching to trackpad wasn't as slow as it was on the tablet. Also, switching between pen and touch wasn't as fast as it was in our first experiment. We found that hypothesis 5, or our hypothesis that switching would be slower and more error-prone on the foldable device, was the only hypothesis to be fully supported. The others were only partially confirmed or not supported. Participants preferred conditions that required less hand movement, and they also didn't like dragging their finger over the fold of the laptop when using touch. Our results inform future interaction design for existing and emerging form factors, and can even extend KLM modeling. In summary, we provide empirical evidence for pointing method switching time and errors for modern input methods. Thank you for your time.